All right, everybody, welcome to the video here for lesson number 9. I'm going to do the whole lesson in this video plus the homework assignment because of the 2-hour or 3-hour delay that we had today. We had an opportunity to get some classes in, some classes missed, so this is a way for you to catch up if you missed. If you didn't have class yesterday to learn the lesson, or if you were in class yesterday and you kind of just struggled with the concept, you could kind of teach yourself again here. So the opening exercise gives us this triangle, DEF. It tells us that there are two sides labeled and two angles labeled, and it asks us, can we answer the question? An answer to that is no. With what we know right now, we can't, because this is a 91-degree angle, making this not a right triangle. So the answer is no, because it is not a right triangle. The second part of the question says, why can't we use basic trig or Pythagorean theorem to find DE? Well, DE is this other side here, and that side can't be found using Pythagorean theorem again because it's not a right triangle. So there's got to be something else we could do. And that's what this lesson's going to be about. So mathematicians couldn't accept that. We couldn't accept the fact that if it's not a right triangle, we just can't find missing sides and angles. So what they decided to do was, well, if I take a pen and drop in an altitude, well, what's special about an altitude is it's perpendicular with the base. I've just created right triangles, and they're going to be similar in some ways, so we're able to go through and find things like missing sides and angles using trigonometry. And they saw that there were all these different relationships, and there's a couple of them. We're just going to learn about one, which is called the law of sines. The law of sines is when you have any two sets of sides and any two sets of angles of a triangle. And you can solve this for any triangle. It doesn't have to just be a right triangle. It could be an obtuse triangle. It could be an acute triangle. It doesn't matter. And what it is it shows that the sides are proportional to the sine of their angles. So the law of sines, which is given to us here, tells us a over the sine of a equals b over the sine of b equals c over the sine of c, where a, b, and c are sides. So lowercase letters a, b, and c are sides. Uppercase letters a, b, and c are angles. And what you can notice from the picture is angle A is opposite side A, and side B is opposite angle B, etc. So let's use the law of sines to try and answer that question in the opening exercise. So those of you that were in class yesterday, you probably heard me say you're looking for matching pairs. And what a matching pair is a set of an angle and a side opposite it. So there's a matching pair. 22 degrees has an angle of 6.74 opposite. We also want to make sure that if we're finding DE, that's my variable. So the angle that matches that side is 91. So we want to make sure that the one of the two matching pairs has the variable in it. Now, like it said on the previous page, we just need to use two fractions. So we're going to say the side of 6.74 is divided by the sine of its matching paired angle, 22 degrees. And that's going to be in proportion to x over the sine of 91. And from here on out, we really just have an algebra problem. So we want to cross multiply here. So I have x sine of 22 is equal to 6.74 sine of 91. Remember at the beginning of this, when we first started to look at trigonometry, we said variables and numbers always go before the trig function. Then we could divide both sides by the sine of 22. So we get x equals, well, whatever that comes out to be in our calculators. So I have 6.74 sine of 91, end the parenthesis, divided by the sine of 22, and I get 17.99. If you're not getting that answer, you're getting something different. Check to make sure that you put a division symbol in, that you have parentheses, and check that you're in degree mode. So in the calculator, it should look like this. Division sign, and you should have parentheses around the 91 and the 22. Let's try another one. So sometimes these questions don't give you a triangle. So in this question, we want to draw a triangle. A, B, C. A is 33 degrees. This is side A. Side A is opposite angle A, so this is really side BC. That becomes a matching pair. So I'm going to have 12 over the sine of 33. Angle B is 43 degrees. And it wants us to find side B. Well, side B is really side AC. So I'll make that my variable. I'll just leave it as B. So there's another matching pair, B and the sine of 43. The side is opposite the angles. Do some cross multiplying. B sine of 33 equals 12 sine of 43. Divide both sides by the sine of 33. And we get B equals whatever that comes out to be in our calculator. So 12 sine 43. Don't forget to end the parenthesis. And we get 15.03. So we're finding sides of triangles that aren't right triangles using the law of sines. Well, the next problem shows us that we can actually use the law of sines for right triangles too. So this gives us a right triangle, tells us Q is 90 degrees. I could just put P and R wherever we want. Tells us P is 57. Side P is 9.3, which is really side QR. And it wants us to find the measure of side Q, which would be side PR. Now we could go through circle 57, say that 9.3 is the opposite side, Q is the hypotenuse, use sine of 57 and SOHCAHTOA and all of that, and that would work here because it's a right triangle. But let's see that the law of sines also works. It'll actually give you the same answer. So I see one matching pair, 9.3 over the sine of 57. I see Q and the sine of 90. Cross multiply, I get Q sine of 57 equals 9.3 sine of 90. Divide both sides by the sine of 57. And I get Q is equal to whatever that comes out to be, which is 11.1. All right, let's keep going. The law of sines can also be used to find missing angles. So we have another triangle here. I don't have a picture, so let's draw one. X, Y, Z. It says Y is 87, side Y is 14, side Z is 12, and it wants us to find angle Z. So I'm going to make that theta. Because whenever I don't know something that's an angle, that's the variable we like to use. So I see one matching pair of 14 and sine of 87. I see another matching pair of 12 and the sine of theta. Cross multiply, I get 14 sine of theta. Nothing's changed so far. Divide this time by 14, because I'm trying to get the variable by itself. So I have the sine of theta is equal to whatever that comes out to be in my calculator. It's going to be a decimal. It's okay. Now, that decimal is not my answer, so I don't want to round that to the nearest tenth. So I'm going to go out well past the nearest tenth, 4 or 5 decimal places. The reason why is I want to use a non or close to non-rounded answer when I want to find my angle. Because remember, to find angle, we use inverse sine. So if I type that in my calculator, because I used an unrounded decimal above, I'm going to get the best possible answer that I can. That gives us 58.9 degrees. And if you had class yesterday, this is where you got to. And if you didn't have class yesterday, just keep going here. So here's the next question. So it says a fire breaks out only 80 feet from a ranger's tower. The ranger needs to run to the water tower to open a spout and blah, 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 blah. The picture tells us pretty much everything. It says how far is the run from the tower to the water tower? So we want to know this side. So that's going to be my variable x. I see one matching pair of 28 degrees and 80 feet. These are opposites of each other. So I can say 80 over the sine of 28. Well, the variable that I want here is x, but it doesn't tell us the angle where the fire is. But luckily, we know that all triangles are 180 degrees. So if I subtract the two angles that we currently know, I get an angle of 106 by the fire. That gives us the other matching pair. So x and the sine of 106. So we're kind of applying multiple skills here to solve this question. Cross multiply x sine of 28 is equal to 80 sine of 106. Divide by the sine of 28. And we get x equals whatever that comes out to be in my calculator. And it says nearest foot, so that would be 164 feet. This would be an excellent test question. Hint, hint, wink, wink. Number 3, we're going to skip. This is kind of like a challenge question if you want to try it. Let's go to the next page where it says Regents questions. So the Regents questions, we're going to see these triangle problems again where it's multiple triangles. But now that we know that we can find missing sides using the law of sines, sometimes we don't have to use sine and cosine and tangent multiple times for these. So let's take a look at A, what it's asking us to find, and B, what we already know. So it says Kathy wants to determine the height of a flagpole in the equation below. She uses survey measurements to find all the measurements in this picture. I get that. And it doesn't really give us a lot of info. Now, we don't know anything about the right triangle other than the one angle. So I know this angle is 52.8. I want to know the height of the flagpole, so this is x. I'm going to make that x. Now, the trick to this question is this bigger triangle here. This is a non-right triangle. So in that non-right triangle, I have a side of 8, an angle of 34.9, and I can actually find other angles here. I know that these two angles together are supplementary. So if I subtract 52.8 from 180, I get 127.2. And if I keep going, I know that all triangles are 180. So if I subtract 127.2 and 34.9 from 180, I get 17.9. Now, this triangle that I highlighted in purple and the right triangle share a side, which I'm going to call y. Y is both here and here. So using this non-right triangle and the law of sines, I can find y and then use y to find x. So let's start by trying to find y, the common side, or the reflexive side here. So I see a matching pair of 8 and the sine of 17.9, and y and the sine of 34.9. I don't need the 127, I just needed it to be able to find that 17.9. Cross multiply and I get y times the sine of 17.9 is equal to 8 times the sine of 34.9. Divide both sides by that sine of 17.9. And I get y equals whatever that comes out to be in my calculator. So 8 sine of 34.9 divided by the sine of 17.9, which is 14.892. Again, that's not my answer, so I'm not going to round it to what it's asking me to round to, so I'm going to go a little bit beyond. So now let's recall back that right triangle. So I have that right triangle. I now know this side is 14.892. I want to know the height of the flagpole, that's x, and the angle is 52.8. I'm just redrawing it down here so I don't have to keep scrolling back up and down. Well, if this is a right triangle, I could use regular SOHCAHTOA here, or the law of sines, up to you. So here's my angle. This is opposite. This is hypotenuse. So it's going to be or the sine function of 52.8 is equal to x over 14.892. Multiply both sides by 14.892. And type it in my calculator. So I have 14.892 sine of 52.8. So I have x equals 11.86, which unfortunately is not the height of the flagpole because of this pesky little cone thing here. So that's really just the height from here to the top of the flagpole. So 11.86 is that. So to have the flagpole height, I have to add that to 1.7. So the flagpole is equal to 13.56 ... and it does say round to nearest tenth, so 15.6 would be the best answer here. That's really like the perfect test question. It's testing that you can decipher between two triangles, you can do the law of sines, and you can use SOHCAHTOA all in the same question. The second question is a problem that we did the other day where we drew two right triangles. If we had more time, we'd go through and do this with the law of sines, but it's really not necessary because I probably wouldn't use the law of sines here. I would probably still continue to do the two separate triangles, so we'll skip number 2. Homework. So here's a triangle, BUG. It says B is 78, G is 42, and side G is 99. It wants us to find side B. So again, I have matching pairs, 99, sine of 42, B and the sine of 78. Do some cross multiplying. Do some dividing. And type some stuff in my calculator. It's really the same exact process every single time. Unless it's a word problem like that last one, it really shouldn't be that hard. Round appropriately. For some reason, some of you are not rounding correctly on your quizzes and tests. Please check that you're doing that right. So next one, X, Y, Z. Angle Y is 125. Angle X is 18. It says side Y is 112, and it wants us to find the length of side Z. Well, if I want to find side Z, that means I need to know the angle opposite it. So if I do 180 minus 125 minus 18, I get 37 degrees, giving us our other matching pair, similar to the fire question in the notes. So I see a matching pair of 112 over the sine of 125. I see a matching pair of Z and the sine of 37. So I have Z sine of 125 is equal to 112 sine of 37. Divide both sides by the sine of 125. And we get Z is equal to whatever that comes out to be. So 112 sine of 37 divided by the sine of 125. And that gives us, to the nearest hundredth, 82.28. The last question is kind of tough. It's a word problem. It talks about a baseball fan sitting. You have to realize that the baseball fan is kind of elevated. He's up in the air or she's up in the air, right? And it says that the angle of depression to home plate is 30 degrees. So here's your line of sight. Here's your angle of depression, 30 degrees. It then says, and the angle of depression to the pitcher's mound is 24 degrees. So if I draw another line to the pitcher's mound, this angle of depression is 24 degrees, meaning this angle alone is 6 degrees. It says the distance between the pitcher's mound and home plate is 60.5 feet. And it wants you to find the nearest foot, the fan to home plate. So the hard thing about this was understanding what angle is actually in the triangle. So the whole angle down to the home plate is 30. The angle just to the pitcher's mound is 24. So the difference between them is 6. That's the angle in the triangle. To redraw the triangle off to the side to make things a little bit easier, this is 6, this is x, and this is 60.5. Now, the other thing that's important is to be able to do this problem, you need more than one angle. So if the angle of depression to the pitcher's mound is 24, the angle of elevation from the pitcher's mound is also 24. So I can put a 24 in here. So then I could set up my matching pairs of 60.5 divided by the sine of 6 is equal to x over the sine of 24. So this is another good question. It's testing multiple things at the same time. Cross multiply and solve. So we get x sine of 6 equals 60.5 sine of 24. Divide by the sine of 6. And you get x equals whatever that comes out to be. 60.5 sine of 24 divided by the sine of 6 gives us 235.4, but it says round to the nearest foot, so 235 is the right answer. I hope this video helped you with this or taught it to you. If you have questions, please come and see me tomorrow. I'll be more than happy to help you. Best of luck.